Hi everyone, here are your notes for section 2.2. We're actually going to be skipping section 2.1, so I know you probably have skeleton notes for that in the packet that I gave you in the beginning of the year. You can either just rip them out, put a big X on it, whatever you want to do with them. You do not need them. We're actually going to be not doing a whole lot of chapter 2, so there's going to be a few of those sheets throughout this chapter that you're not going to need. So we're really just going to be doing 2.2, 2.3, and 2.5 for this whole entire chapter, and that's it. So all the rest can be ignored. So in chapter 2 is all about thinking, and can you think? Hopefully you can think. Hopefully you have common sense, right? So common sense, if this looks like it's an obtuse angle, probably is going to be an obtuse angle. Make sure that your, gosh, I like hair in my mouth. Make sure that your answer probably is an obtuse angle. If this is obtuse and this is acute, they're probably not going to be equal because there's no way an obtuse angle and an acute angle would be the same. So make sure that your thinking caps are on and you're kind of thinking, well, does this make sense? So other than just using common sense, we do use different type of thinking in geometry. Well, not different types because you use this thinking all the time, but you may not have names to it. So the first thing we're going to cover today in section 2.2 is what we call conditional statements. You have seen conditional statements before, probably in your science classes, and maybe in other parts of your life. So what is a conditional statement? Please write the following. A conditional statement is a logical statement that has a hypothesis and a conclusion. Okay, so when you guys were doing your probably chemistry labs or some type of lab in a science class, you might have had to write a hypothesis, what it is you were hoping or expecting to happen, and then at the end you came up with your conclusion, right? What did happen when you finalized your lab. So the same thing applies in geometry. So usually we write conditional statements in what we call if-then form. So here's an example. If it is raining, then there are clouds in the sky. Probably is a pretty accurate statement. So the hypothesis of this conditional statement is the part that follows the if. It is raining would be the hypothesis. My conclusion is always going to be the part that follows the then. There are clouds in the sky. So I hypothesize it's raining outside, which means we probably could conclude that there's going to be clouds in the sky, right? Because that's where rain comes from. So that is a conditional statement written in if-then form. So you may be asked to be able to rewrite a conditional statement in if-then form. So here is a conditional statement. Two angles are supplementary. Remember, supplementary means they add up to 180 degrees, right? Two angles are supplementary if they are a linear pair. So how do I rewrite this in if-then form? Well, this one's really nice because I already have the word if in there. A lot of times in these, you kind of take the vocabulary word. So what's the vocabulary word here? Linear pair. And we put that as the hypothesis. So I'm going to rewrite this as if, and try to grammatically make it make sense. If two angles are a linear pair, so are a linear pair, then what? So are a linear pair, then they are supplementary. So now I just rewrote a statement in if-then form. Okay, so my hypothesis is I have two angles that are a linear pair. My conclusion is I conclude that then they would be supplementary. Okay, so conditional statements. And the reason why it's important to be able to write things as conditional statements is sometimes you're going to be asked to come up with a counterexample. So a counterexample is an example that proves that the hypothesis is true, but the conclusion is false. So once I have it in that if-then form, my counterexample needs to be true for the if, but not true, so false for the then part, the conclusion. So if we have it in if-then form, it makes coming up with counterexamples a lot easier. So come up with a counterexample that proves the following statement to be false. So I have the statement, if the product of two numbers is even, then the two numbers must both be even. Okay, so my hypothesis is the product of two numbers is even. So let's think about this first. Product means multiplication, right? So if I'm multiplying two numbers together and the answer is even, so I'm taking a number, multiplying it by a number, and I'm getting an even answer. My conclusion is that those two numbers must both be even. So these two numbers right here must both be even. Is that necessarily true? So coming up with a counterexample, I need to come up with maybe an odd times an odd to get an even. Or maybe even an odd times an even to come up with an even answer. Can you come up with any actual answers? Let's do odds. Give me an odd number. 3. 3 times another odd number. 3 times 9, that's 27. That doesn't work. Let's do 5 times 7. That's 35. So that's still odd. So that doesn't work. So odd times an odd probably is not going to get us a counterexample. So let's ignore that one. Let's go down to this one right here. Give me an odd number. 3 times an even number. 2. 3 times 2 is 6. That's even. Look at that. I just came up with a counterexample. So 3 times 2 is equal to 6 is a counterexample. What will be another one? 5 times 2 equals 10. 7 times 2 is 14. 4 times 7 is 28. Any odd number times an even number will always result in an even number. So there would be my counterexample. So your example is a specific example. 3 times 2 gets me 6 would be a counterexample. 5 times 2 equals 10 would be a counterexample. So your counterexample should be an actual example, not another conditional statement. Sometimes students will try to do that. Okay? All right, moving on. So now we have our conditional statements. We should be able to come up with a counterexample, right? So let's just pause for a second. Let me talk through some counterexamples. So if I say something like, if it is hot out, then I live in the desert. Can you come up with another place that's hot that's not the desert? Florida. I don't think they have any deserts in Florida, right? It's probably hot in Florida. The rainforest is hot. That's not the desert. So those would all be counterexamples. Or if I said, if an animal has whiskers, then it is a dog. What would be a counterexample? Well, can you give me an animal with whiskers that's not a dog? A cat. A bunny. Right? A squirrel. Would all be counterexamples. Okay, so make sure you have that. All right, so then the last thing that we're going to cover in this section is what we call a converse. And a converse is just a manipulation of a conditional statement. So when you manipulate a conditional statement to make a converse, what you're going to do is you're going to take the hypothesis and the conclusion and you're going to switch them. So a converse is when the hypothesis and conclusion are switched. Okay, so when the hypothesis and the conclusion are switched. Okay, so if I was saying the conditional statement of if it has whiskers, then it's a dog, the converse would be if it's a dog, then it has whiskers. Well, that's true, right? I would hope all dogs have whiskers. That would be a really weird dog if it didn't. Okay, so let's go ahead and do an example here. Here we have the conditional statement, if a person plays a guitar, then they are a musician. So, what is my hypothesis? Well, my hypothesis is a person playing the guitar. Here's your hypothesis. Your conclusion is that they are a musician. So now I'm going to flip-flop those and write it out as if, and again, try to have it be grammatically correct. I could even talk in correct grammar. If a person is a musician, then they play the guitar. So that would be my converse. So I just flip-flop the conclusion and the hypothesis. All right. So once we have that, so here's our converse. If a person is a musician, then they are a guitar player. Is that true or false? If a person is a musician, does that mean they play the guitar? No. All right, that would be false. What would be some counterexamples? A counterexample, they could play the piano, or they could play the flute, or they could play the drums. So I would write out for my actual answer of the counterexample as a musician could play insert your musical instrument here. I'm going to do drums. Okay, so that would be your counterexample. All right, put a big X on what's below the biconditional statement. We're not going to get into that, so you don't have to worry about it. So we now have concluded the 2.2 notes. Please move on to your next assignment.